All right, thank you very much. Okay, yes, so I chronically do not use an engine. And so this talk is about how, okay, it's playing. Okay, yep, thank you. Cool. Sweet, okay. Cheers. Anyway, so anyway, like I was saying, don't use an engine. So this talk is basically about how to make your own rendering if you don't use an engine and how I've done it. So now you've seen what the game looks like, right? So it's basically one of those like 16 pixels square games, right? Anyway, cool. So, and I'm glad that the video worked. That's like an all-time first for PowerPoints as well. So that's great. Huge. Okay. These were just the contingency plan for if the video didn't work, but screenshots. Okay. All right, cool. All right, anyway. Okay, starting from the beginning. So you might have a folder full of assets, right? Folder full of PNGs. Okay, so we have a folder of sprites. How do we draw it? Okay, so first thing you want to do is load it onto the GPU. So this is what it looks like for our game. Yeah, so, and look, the dudes are like this big. It's mostly like the animations and like the splash screen and stuff like that. But yeah, anyway, so that's like the texture memory, right, for the whole application. Okay, so we're drawing sprites. Now, what is a sprite? A sprite is a square with a texture on it. So, okay, we're drawing squares with textures. Okay, it's a textured quad. Okay, a square is two triangles. Now, GPUs can draw triangles. And so this image of a wizard gnome is showing you how two triangles makes a square, and you might put a texture on it. Okay. Okay, so one triangle is made of three vertices. A vertex has got position, color, and UV coordinates. Okay? So, yeah, and so the attributes are defined for every vertex. So yeah, we end up with this big pile of vertex data, and so on the wire, you see this all, and that's also what the repacy pact is for. So this all just gets turned into a stream of floating point numbers. It just gets just fired at the GPU every frame. Okay. Okay, and so we're talking about texturing, UV mapping and texturing. So yeah, so textures is literally just 2D memory, all right? It's 2D memory, and the UV coordinates are 2V indexes. Anyway, so yeah, so you see you can see this is like what each vertex has, like the numbers, and that's like where the texture like starts from, okay? So yeah, remember this. So that guy had like 0.68, and this is like it's zero in that corner, and it's 1 in that corner. So like that's singling out like a tiny little like section of the sheet. So that's UV mapping, right? UV mapping in a nutshell. Okay, color. Color does not need a lot to be said about it. It's RGBA. It's from 0 to 1. We do have alpha. We do use alpha. Now we don't actually use color very much because my guy will say something about like it's not on palette or whatever. I don't know what he's talking about. But we do use alpha to like fade in and fade out, stuff like that. Okay, position. So yeah, on the GPU, there exists this thing called the NDC cube. So basically, -1 and 1 in every direction. So it will draw the things that are between -1 and 1. If the things are not between there, they will get clipped. And the z-axis is like the depth to the camera. So we're doing z ordering based off the z coordinate of the position, right? Bonus information, the 3D games uses a perspective projection matrix to take a 3D scene and then crunch it into that space, right? So, great stuff. Okay, and it all comes together with this line. So this is basically texture lookup gets you the color of the texture at that point, times by the color, and that's it. That's the fragment shader, right? Cool. Okay. Okay. Now there's one more thing, the post-processing. So yes, back when art looked like this, screens looked like this, right? And so you get this kind of nice effect. So we mimic this. So this is what it looks like without the CRT filter. But then with the filter, it looks like that. Ooh, thank you. Yeah. Okay, and yeah, you can sort of see the scan lines. All right, this is a crazy slide, which you'll probably either understand or you won't. But so basically, we do a second render pass where we take the output, we take the no filter image, we save it in a texture, and then we kind of simulate that it's coming from a CRT screen. So we get the subpixels and separate them. That's why that image is there, even though it's not exactly that. And we use not quite a linear function, because linear is ugly, but we use smooth polynomial function. So that's what that's all about, you see? Bit of the old 3x squared minus 2x cubed. Very good function. Okay. And now this is just a little bit more comparison. So you can kind of see that you end up with the chromatic aberration because of the sort of subpixel separation. So yeah, that's like the CRT filter. Yeah, thank you. Cheers. And so that's just another image. It pops pretty good, doesn't it? Yeah, okay. All right, this is the plug section. So if you think it's interesting, definitely shoot me an email. That's very cool. Very happy to hear from you. Very happy to talk about this stuff. And yep, and that's Tommy. This is my other half on this project. And of course, wishlist Gnomes on Steam, please. Woo! Yeah. Thank you very much.